Are we live, everyone? Yes, we are. Okay. Wait. Yeah, let's do that. I am surprised. I always had to press a button to go live, but not this time. Let's set everything up. And there it is. Okay, let's open up the chat. There we go. Okay. Hello everyone. We are going to figure out the syntax. We're gonna write a programming language, and that's gonna be great. All right, first of all, we're going to make a directory, call it, oh, yeah, let's turn that off. Okay, let's make a directory and we'll call it, not like that, there, DDA language, sure, and don't worry about what you just saw there. We're going to do that, and all right, cargo init bin. Then, all right, now that that's done, let's do the cat cargo toml, cargo and pest derive, which are the libraries that we're going to be using for this whole thing. Now it has preprint, not bootstrap and source, grammar extras. Sure. Nothing that we need to worry about. Okay. Cat cargo toml. We're going to be using pest 2.7, which is good. Cat source, ls source, sorry. Envim main.rs. It has been a while since I've programmed Rust. So yeah, it's very Rust coded. We'll see what we're doing. So we're going to be using the pest parser instead of something else. Yeah. There is nom as well, and it's a bit more of a popular choice, but we're going to be using pest, which is the elegant parser. It is a general purpose parser written in Rust with a focus on accessibility, yada, 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 yada. Everyone loves Rust. Rust is a great language. Welcome to the stream, moderator. All right. We've got a lot of resources here. We've got this, we've got this, we've got this. For the thumbnail, all right. This one. So, first of all, the language that we're going to be making. How does it look? What's it look like? It's going to look like Lua, because a lot of the mods in the older versions of CDDA that still supported Lua were written in Lua. But the problem with Lua is that it's got a lot of... I mean, it's not problematic. The syntax is actually pretty easy to figure out. Yeah. The only problem is that it works with indentations. And I don't like indentations. Indentations aren't fun. What we are going to do, first edit, we are going to go here and open a new file. Yeah. We're going to open a new file and call it example dot, not CLUA. I need a thing for it. You know what? Just .txt. We'll just write an example.txt. And we are going to write the example code that we want to parse, first of all. Now, I've already got a little bit written right here. Yeah, don't worry about that. There it is. We are going to add a type to this language. First of all, it's going to have a type, either string or an integer, and these are going to be able to get converted between each other. We'll add methods for that, and we're going to tree walk it later. We're going to have to parse white space, ASCII, text. The only problem with the parser that I'm using is that it is not able to handle Unicode. Unicode is problematic. Your internet is garbage coded. Well, that's great. The parser is not going to be able to handle Unicode text, which is very bad because we're going to be using ASCII all over and we're going to just be locked into English. But we'll cross that bridge when we come to it. All we have to do right now is open up a grammar file. What's the grammar file, you might ask? Well, let me tell you. Here we go. The tutorial says that we need a declaration statement, identifiers, code, whatever. We opened it, pest 2.0. Looks good. Okay. Where is the code? Where are we going to put all of that? Choice operator, it's like or else. So it's basically like or. Yeah, okay, makes sense. When we do that, we are going to, grammar.pest and source. Doesn't matter where you really put it. All you have to do is just put it somewhere. Grammar.pest. There we go. This is the pest file. Now, we need a declaration statement, and the declaration needs identifiers. Identifiers and everything need ASCII. I've already done a little bit of work to see how we can come up with that because I am new to this, very new to this. So we're just going to learn as we go. This is the basic stuff that I've copy pasted from other sources right now. Our grammar.pest is going to look like this. We have alphanumeric, we have digits, and then we have underscores. Then we have new lines and white space, which we have overwritten because this is provided by default type of shit. Then we have an identifier and it has the atomic at the start. So it means for everything that you've put here, like a digit, alpha, digit, underscore, etc., it is not going to treat those as separate tokens. It's going to just treat all of them as one and call it an ident, then use it as a span. Then we have a string literal, which uses an inner, and the inner uses ASCII. But this is broken, and I'll show you why. We have to say ASCII alphanumeric, and then do a tilde, which means and, I believe, white space. I think that's it. No, it's not it. What did I write last time? ASCII alphanumeric white space. Is that gonna work? No, it's not gonna work. How about if I remove this? Okay, that works. Is there any other thing that doesn't work? Yeah, a lot of symbols in that inner thing don't match. So, we are going to open up not the introduction, the docs.rs for pest. Docs.rs pest. There we go. And as soon as this opens up, we're going to be able to see the stuff that we can use. Where is it? ASCII digit, non-zero, bin digit, arc digit, alpha. ASCII. Okay, we want to match ASCII. Now I'm not sure if this is actually going to work or not, but okay, let's try it. Let us try it. Instead of saying ASCII alphanumeric, we're going to just say ASCII. Declare string. Well, that did not work at all. This one also doesn't work. What's the problem here? Do I need to not group it, maybe? Okay. All right. Looks like it's not gonna work. Oh, shit. That makes a lot more sense. We have to make a group. Declare string. Well, that's problematic. It expected an ident or a string literal. And string literal expects an inner. Inner expects ASCII. Now, why does ASCII not work? Your guess is as good as mine, if I'm honest. Expected ident or string literal. Hello there, Castro is trying. How are you doing today? How are you doing? Well, why doesn't it work? Don't tell me I have to write all of the characters by hand. I might. Okay. Well, we're going to have to put that in there so that we get matched. Oh, alphanumeric. That matches, but if you change it, it's not going to match. Okay, 1 second, I'll be. Right, okay, hello everyone. It is in the blazingly fast memory safe programming language Rust. That is very true. All right, where were we? We were trying to match all of these. Now, if you wanted to pull up the ASCII table, there it is. This is the ASCII table. We are going to have to find the symbol, the character, if you would, and okay, which character does it start at? Starts at space. It ends at tilde. Okay. Now, if I were to actually, instead of doing alpha digit, everything, and then set that as a rule, and then the rule would start us off in space, tilde. That is the correct rule, as far as I'm concerned, because this is showing up. So what we have to do is we probably have to say everything, right? If I can spell, that is. Come on. Oh, wait. What do you mean? Can I not duplicate it? This makes no sense. What the hell? How about inner? Okay, inner works. What about string literal? It's not a string literal, but what if we go to declare string? Doesn't want to work. Doesn't want to work for some reason. All right. Instead of that, we're going to say declare string literal. It expects that and t. Why does this not make sense? You know what? Let's change it. Let's change the text. Crying over pegging. Yeah. Pegging. You'll love to see it. Does it just not go up there? I'm not sure if it doesn't. Yeah, maybe it doesn't. Maybe it doesn't. Instead of everything, we are going to say string literal, and that doesn't make any sense. That makes no sense. Let's look at the pest book. Maybe the book has an example where we can actually check it out. CSV. CSV has a record and a record count, numbers, fields, ASCII digit. It only supports the digits though. So this is the parser API. I've already read this with the tokens and it matches rules. Then it sums, etc., etc. Then we have the parse method. And then we have spans and positions. How about INI? Now, initialization files, these are the Windows files. I don't use Windows. Imagine using Windows. We're going to go right here, writing the grammar. ASCII alphanumeric. There is no way that anything actually consists. Can we not make a simple string for fuck's sake? Why is it so hard to make a string literal? String literal grammar in peg. Let's see if someone's already written this. Parse string, quoted string. Oh, now Stack Overflow wants to verify I'm human. I'm not human, I'm Iranian. We're gonna verify. Hopefully it's worth it. Parse strings without any surrounding things. Okay, this is your peg.js rules. Alright, I see ya. Start text. Text has a body. This does not look like peg. Type literal, ID literal, description literal, char double string character, string join double string character. I'm gonna actually cry. I'm actually gonna cry. All I want is to be able to accept punctuation and the like in my strings. And it doesn't want to work. So what if I just give up and go the funny route? You know what the funny route is? We just add these by hand. Yeah. What other punctuation is there that we haven't added? I would like to see that in the chat. Okay, not a double quote unless it is this. Wait. Wow, okay, that's funny. So we can't parse this, or can we? We can parse it. No, we can't. We have to do this. And then it just somehow miraculously works. Or does it? Okay, we want to say that is very funny, like some old style emphasis. It parses until very and then it breaks, as is expected. But then okay, we have a string literal here. and a string literal here, and then it parses till the end. I guess that works. Then we have this, dot. All right. What other rules do we have to add for the punctuation? I guess tilde. But I really expect tilde to already be a thing. It isn't though. So it's not gonna match. All right, okay. Is the dollar sign gonna match? No, it's not going to match. I really have a feeling that there has to be a thing with the symbols. There has to be something with symbols here. Oh my god. Okay. ASCII. In parameters. Of course it's not. Of course it's not. Do I have in my GitHub, am I logged in? Yes, I am logged in. Cicada. Cicada Unix shell. Let's check the grammar for the Unix shell. Where is it? Parsers and grammar.pest. KW list, dummy do, if hide, if else. And that's an expression we could learn from this. ASCII alphanumeric, and there's no string literal. There's no string literal here. Hate for me, Ron. Thank you very much. Appreciate it. Locust.rs. We have locust here. Why is it named locust.rs? I have no idea about that. Is it written as a CMD? I don't think it is. CMD normal, which uses not KW list. Oh, this is a lot more complex than I originally thought, I'm going to be honest. This is a lot harsher than I expected. Yeah, that's a lot harsher. Mainly because I have to add the symbols one by one. All right. Example JSON. JSON should definitely have something. JSON should definitely have a string. All right, we're going to define the AST and Rust. And then when writing the grammar, they got white space, they got an object, they got an array, and string. There is that. Makes it a good fit for pest's implicit white space. Value has an object, an array, or string, or number, boolean, null. A string can be any of these. The char rule uses the idiom any. Now, what is this idiom? I'm not sure. Predicate. All right, where is any? You know what? If it works for the string, then it should work here. If it doesn't start with this or this, then any. Or if it is this, then you do this, 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 this. ASCII hex digit. Yeah, does this work? Let's copy and paste it. Let's copy and paste it and replace our own setup. We're going to copy and paste it, and instead of whatever the hell we have going on here, I'm going to replace the string literal and make it this. Then the string literal is going to be like this. Expected alpha. What? What do you mean expected alpha? Your string didn't expect alpha. Oh, because I'm on alpha. Okay, how about I go on string? Inner, that is very funny. And if I don't escape it, yeah, if I don't escape it, that happens. But if I escape it, well, it does work. And it should support virtually any character that we throw at it, unless it needs escaping. Does it support Unicode? Oh my god, it supports Unicode. Oh my god, it supports Unicode. Chat, we're balling. Chat, we're balling. String inner. Is there a way I can flatten that? I want to flatten it. I really want to flatten it because it has inner in it. Not that, that's still Persian. Please switch to English. All right, we flattened it and we still have implicit white space, which means our string literals are correct. Our string literals are correct. What if we said, what if we did this and then did a backspace U, ASCII hex digit, A, B, C, D, F. ASCII hex digit 4. It just goes. I don't think we need to add support for the Unicode code points, but sure, let's keep it. It doesn't hurt to keep it. Even though I have no idea what /b, /f, /n and r, those are character terms. The rest I have no idea, but as long as it works, and I'm not going to touch it anymore. So let's just copy the char and inner and string right here. Then we are going to bring it into our grammar pest. It is here. Shift V, Control Shift V. Stringlet. All right, we've got it. That's great. We have a string inner, and instead of saying stringlet here, we are going to switch that to just string. Now, if we've done everything correctly, we should be able to go back, remove this, and do declare string for this. And then we're going to declare string, we're going to get an ident, funny shit number 1. Then we're going to get a string that says test. That's crazy. Quoted. Our strings are done. So pest does in fact support Unicode. It's just very fucking messed up in how it tries to support Unicode. But Unicode is only supported in strings. It's not supported in idents, it's not supported in keywords, it's not supported in any of those. So now that we've done declare string, we can also switch this out for we want real string to be set to funny shit 1. So we are going to just do this, except, and you'll see we have an ident real string. That's the ident that we need to set it to. It's a pair. We're going to be using them as pairs. And then we're going to set it to this. So if that's all right, and if we look at the craftinginterpreters.com, we can see that if we go to previous, a tree walk interpreter. Yeah, we're going to afterwards try to change this from a tree walk interpreter to a tree walk compiler. We're going to create the ASD, we are going to parse it, and after we've parsed it, we're going to build the abstract syntax tree, and then we're going to walk the syntax tree. Once we walk the syntax tree, we are going to get some JSON and create the JSON based on some other directives that we'll hopefully get to parsing later. But let's return to the actual thing that we want to do. Now that we've managed to declare strings, we have to learn how to declare integers. It's not really an integer, it's a number. So we're going to say declare number. Sure, okay. And instead of star, we're going to say num. Originally, I thought I would go with int, but I feel like int is pretty complex. I mean, not complex. Int is going to give you the predisposition that you're expecting an integer, not a floating point. And we want a floating point. We want to support both floating points and integers. So again, everything is going to be the same, and we are going to have this equal sign. This equal sign string, I think I'm actually going to pre-process. Yeah, I was thinking about adding to numbers, like incrementing them by this value, like this. Num funny, and then this. I was thinking of adding this as a language feature, but I think I can just pre-process this to say num funny plus 1. And after we pre-process it, it's just going to be, oh shit, oh god, that's reminded me. If we do pre-processing, and if something like this happens, or if we want to concatenate text like this, we don't have any rule to support concatenation. Shit. But it's not going to be that hard to add it. It's not going to be that hard to add it. All we have to do is go back to the introduction on the test book, and you'll see that in expression, what's the term? Terms is silent. Term is either a number or an expression in parentheses. But then that's recursive, isn't it? All right, thank you for joining. Take care, stay safe, bye. I will see you later. Operation. What the hell is that? Wow, that's all for expressions. That really is all just for expressions. That num right up here at the top, that supports both normal integers and floating point integers. And it also supports the scientific notation. So we are going to copy that, remove the scientific notation, and just take that. Then operation, I'm thinking, yeah, we're going to just take this and bring it up here. Right up here, we'll see a num. That's done. We're going to remove the scientific notation as a whole because, let's be honest, who cares? Then we have an integer, and we can have a negative integer or a positive integer. We can have a negative floating point or a positive floating point. Okay, now for operations, I have a feeling that we're going to add all of those as operations, because obviously we're going to have to support mathematics in our language. And I love this syntax that they've come up with here. Wide mode, yeah, why not? If we're using the editor, let's just keep it wide. I love the syntax that they've got going on here. But we do need expressions and terms. And calculation, well, I don't think we actually need that, but we're going to write down this expression and this term. All right. Now we have terms, we have operations, and we have a lot of other things. So declare num. Instead of doing that, let's first check our expressions. Does 2.45 plus negative 2 make any sense if we were to try and treat that as a term? So term just has a number, but expression has a number plus and plus num. and then that num is negative. So we've succeeded. We've actually succeeded in doing what we wanted to do. But we also want to be able to subtract. Oh wait, if I go to another line, no, it has to be on the same line, which is good. That's what I want. And now if I wanted to put you in an expression and yeah, we can recurse those expressions. And because the term is silent, it just uses itself as a tool to recursively add onto each other. It's also an or else, so it could either be an expression at the beginning, an expression at the end, or any other combination of the following. Then we have subtract, divide. Have a feeling all of it works. Yeah. But the problem starts when you want to add an operation in the middle of a string as an optional thing. So this whole thing, setting up, is optional. You could probably add that, make it bigger. Instead of declare num, we are going to make it an expression. Could a number by itself be an expression? It can. It can be an expression. So if we go and do num, not num, instead of writing an expression, we're going to do declare num. And then we either use ident or num. And for ident, well, we'll say funny. That's an ident. 2. Floating point. Expression. All right, all we have to do is write a thing that converts the expressions into mathematical representation when we're writing the tree walk interpreter. But so far, so good. So far, so good. The number works. The number works. We get declared numbers, and we can make variables now. All of this just to make variables. Isn't that beautiful? But it's going to get easier from here since we have our stuff set up. The thing with declare string is that we have to add a silent rule that says string assignment var. So we can concatenate strings. Hopefully, I'm actually going to map this JSON function, the string assignment var, whatever it is, I'm going to be able to map it to a JSON method that in the effects of the effect on condition that we're going to be using, it just makes a temporary variable, formats it like the format macro that we have in Rust, and then afterwards, it's going to output it, yeah. So in the string assignment var, we're going to have the simple thing. We're going to have the string. If we don't have the string, we're going to have a group, which is an string. We're going to take, let's first silence this. If it doesn't, we're going to do what? Good question. As you can see, the term and the expression is recursive. So string assignment var is also going to be recursive, I'm thinking. It's going to have either a string or a string and then an add. Yeah, okay. Then another string. And it's going to be like this. So declare num, it does actually work, but if we do string assignment var, how does that turn out? Good question. We're going to go to declare string, and instead of saying num, we're going to bring it up to ident. Then we're going to have a string, which says hello. Good enough. Now we have some symbols. You have to escape this, yeah. After we escape this, it works, all's good. But what if we have hell plus O? It expected to declare string. Shit. Oh, well, that's not what I expected. It's either string or... Hold on. We're going to bring it up here and we're going to say age plus... Instead of age, we're going to go to string assignment var. We have this, we have that, have a. Does it not support implicit white space, or is it just my problem that I can't make this work? I think this is a problem that I've introduced into our code. So we're going to say stir expert, and we're going to copy that stir term syntax that we have up there. And the stir term syntax, well, it's pretty simple. It has a string or a string expression. And then the string expression, that is a stir term, which then leads itself into an add operation and then a stir term again. And it copies that. Now, stir expert is left recursive. Prat parser might be useful in this case. But how does the left recursivity not cause a problem up there? Oh, is it because... I don't think so. The left recursivity doesn't cause a problem when I remove that, but when I still have it, it causes a problem somehow. Okay. Oh. What do you mean? Left recursive. Well, you don't see any problem with this. So why is there a problem with my left recursiveness? It's literally the exact same code, just changed a little bit. Even the string that we're using has the atomic behind it. So I have no idea why this is a problem. Rule stir term is left recursive. But that's also left recursive. Is it because I have to add like parentheses? Yeah, I have to add parentheses for some reason. Left recursive, is that like it'll just keep matching itself over and over again? Because I think it might be. Let's try not being left recursive. Expected in alpha, we're going to switch that alpha to a string expression. Then we have the string, and we have another string, and it adds itself to it. Hold on a second. Can we just make it like this? Wait, if we could make it like this, could we just make it like this? And then this? Yeah. And implicit white space doesn't matter either, so... Does subtract matter? No. Equal sign? No. Well, that's certainly interesting. I have no idea what I did, but whatever I did, it worked. Sure, okay. Just try whatever works. Stir concat. and instead of stir expire, we're going to say stir concat, because that is the only thing that we're going to be doing. So if we run a declare string here, we're going to be able to see that we have a stir concat right here. It has string hell plus O, but if it wasn't concatenated, what would it be? It would be a string by itself. So is there a way that we can make it so this is just a simple string as well? First, it's going to take precedence. It's going to match just a single string if it exists. And if it doesn't exist, or if it is not exactly that, it's going to match this. It's not going to match this. Okay. If it starts with a string, then it's better. It's going to end with that. Sure. Okay. Okay. What if we reorder it? Is there any chance that reordering it might have any... I don't think it would, how it would make a difference, because first of all, it's going to make a string concat. It's going to match that one. So yeah, it's not going to make any differences, but doesn't really matter. We can just flatten the stir concat. Even if we get to the code gen phase, all we have to do with the stir concat is figure out whether it involves an ident or it's just more strings that have to be concatenated. And if it involves an ident, we're going to code generate it so that the JSON code, quote unquote, that Rust is going to use, not Rust, that CDDA is going to use, it concatenates the variable. But if that doesn't exist, well, we're just going to concatenate the string at runtime, or at compile time, rather. So it could either be an add string, or it could be an ident. We have to make sure that that is true, because if we have a stir concat and we say funny, it's going to expect a string here, right? It's going to expect a string here. But what if it didn't? Is this going to work? I've just switched it around. It's not. It's really not. Okay, well, first of all, we have to make this a group. I think, yeah. We're going to make this a group and then say some other. And then when we make this a group, it either switches between treating it as an ident or treating it as a string. Now, I'm not really sure how peg works. I'm still very new to pegging, but I can clearly see that this functions, so we're going to keep it. Stir concat has an ident, it has an add. And then as an add, it has... Could we just remove the add part and put a plus in there? Yeah, why not? Why do we just make it harder on ourselves? So we have to interpret the plus symbol and drop it. We're just going to match the add. And even if it's added together, like this, no white space, it's still going to parse it, which is exactly what we were looking for. So now, if we try to declare a number, obviously, we're going to be able to declare a number. Slight problem. When we want to declare a number and we have an expression or an operation or the like, we also have to add support for changing the term. We have the operation right here, and the term, it has to be constant. It has to be a 1 plus 1 type of deal to actually work. But what if it isn't 1 plus 1? What if it's a funny ident? Yeah? So, stir concat term expression. Also, we're getting 0 viewers. God damn, this is not at all a good time to stream on my channel. Not at all. But yeah, operation then, and afterwards, we are going to make a group here, and it's either going to be a term like last time for the string, or going to be an ident. Fuck, why isn't it working? I swear I added it, like it asked me to. Is it because it has to have a number at the beginning and then an ident at the end? Yeah, it seems so, but I really don't think it should matter. Yeah, so we're gonna add a term or an ident. So now we could even do things such as add ident to an ident, or add number to an ident, or ident to a number. Now, could we place these in expressions? Yes, we could. We could make an expression in an expression, and then we could divide it by an expression in the expression by multiplication of 2. Wow, that's very recursive. And I do not want to flatten. I do not. Thankfully, I'm not going to worry about it right now. But these expressions have to be flattened when we want to actually convert this to JSON for CDDA. Slower than the recommended bitrate. Well, maybe that's all the bitrate that we need. 0 viewers. Absolutely no viewers. How long have we been live for? An hour. As soon as it gets to 2 hours or something, and we still don't have viewers, I'm probably going to stop streaming. So we can stream at a later and more sensible time. Because this is not sensible. Num funny, ident num funny. Stir. Ah, this is working. We can remove the everything because now we have a thing with a char. And the inner in the char and this all makes perfect sense to me. The num int operation expert term stir concat. Well, that is certainly complex, isn't it? And we still are doing pseudocode. So, now that we have this, we are going to make the pseudocode bigger. After adding variables, what's the thing that we need to add? Statements and function calls. Because, we also need to add a specific type of variable called an array or a table. And these are going to be a pretty complex thing to tackle because CDDA doesn't support any data structures besides, well, variables. Simple. This variable is this name and it has this value, be it a number or a string. What we have to do is we have to add an abstraction on top of what we already have, which is our own language. We have to add an abstraction. And then after we've added an abstraction, then we're going to be able to, well, compile that abstraction, compile that abstract syntax tree, and actually use it as a table, like we can use tables in Lua. The problem is that I don't know how to program in Lua. I've programmed in Lua ages ago, but on this cheat sheet, you'll see the tables are complex structures. In these tables, you have, well, tables, empty table, you have a named variable that is this, which is basically like a dictionary in Python or a hash table, if you want to get specific. Or you could define functions as a result to variables. Like, not functions, you could define functions as variables and then you could call those functions. And then you could define arrays in tables. So if you wanted to, it's one indexed. Mine's not going to be one indexed. I don't care. So whoever has to port mods from Lua into the new version and compile it using this into effect on conditions, I don't care what you're going to do. This is going to be a zero indexed language because I hate one indexed languages. And a hash is going to return the length of that, but I don't think I'm going to return the length. I'm just going to call the abstract syntax tree. I'm going to add a function that is .length. And then on compile time, I'm going to compile it and say that this is the length of the variable. How are these tables and arrays going to work? Great question. I'm glad you asked. These arrays and tables are going to work exactly like they do in CDDA. And they're probably going to operate on that one system I programmed for CDDA effect on conditions that let you dynamically allocate. That's right. Dynamically allocate things. You are going to be dynamically allocating things. How are you going to add numbers and stuff? Good question. I'm not sure. Because, well, the thing about this is that, you can define static. You can define static arrays like this. Or you can define this and you can add functions. So all we have to do is we're going to have, when we're implementing the tree walker, we're going to have to figure out the static size. And then that static size is going to be pre-programmed into variables because, hey, this exists. This is going to be modified in that way. That's going to be modified in that way. And this is going to run with this function. But after all of that, it's all going to be dynamic. It's all going to be dynamic because no matter, the holding problem says that no matter how hard we try to actually predict when a program is going to hold, we're never going to figure it out. A program can never predict another program's holding, and that goes for compilers. That's a big problem. So, do end syntax. All the things that you can see right now, do end syntax. I don't want any of those do end syntax. Just like I changed the variables to become normal, I'm going to change the conditionals and whatnot to also become normal. But how we're going to do that is check Cicada. Cicada is going to have a KW fee if fee. All right, conditionals. Thank you for conditionals. I'm going to copy that and I'm going to bring it over here. Then I'm going to add that to this. Then we have alpha, bravo, sure. We're Oscar Mike on our way to figure out this whole language. The parser. All right. Now that we have the parser, we're going to go back to look at Cicada and we're going to go look at the Lua cheat sheet. This Lua cheat sheet, you'll see right here. In these conditionals, we have if condition, then else if condition, then else if. And the way the way I want to handle it, rather, is I'm going to bring this Vim here. We're going to go to example.txt and we're going to make that a little bit smaller because it's taking up a lot of space. The way I'm going to handle it is I'm going to have an if, then I'm going to have an expression. It's going to be an expression here. Yeah, and then I want to have it then as well. But instead of using indents and whatnot to figure out the statements, I'd rather have something like num integer 1 plus 1. How about that? We've already implemented this. And then we are going to have a return. Return integer. Of course, this has to be in a function, otherwise it'll error out. But that's for later to figure out. Instead of using indentations to figure out statements, though, it's going to end in semicolons. So in that case, we're fine. If condition How are we going to end it? Well, because we're not using something like, I don't know, these curly brackets, which are always lovely, since we're not using that, we have to rely on words. If, then, end, like Lua is. And instead of else if, I mean, sure, what's the problem with keeping else if? There's no problem, we can keep that. Condition, then, and this one, num, test 3, return test, and then we have an else, return 0, because it has to support idents, strings, and numbers. So we're good. This is all of the things that we need to parse. So I'm going to copy this text, yank it, bring it over to the test parser that is going to be parsing this, and we're going to get to work writing on the parsing rules. Oh, we have an extra viewer in. Hello. Who is that? Doesn't show up in participants. Well, that's okay. I hope you enjoy the stream while we're figuring out how to write this. How we're going to write this is an if statement. And an if statement obviously needs a condition, right? So an expression if start of parser is optional. If break. What the fuck? Where is that? If head. If head needs a KV if and it needs a test. Now that test is a group which shouldn't start with a new line or a dummy then or a dummy do, which is a silent way to basically describe a semicolon and do and then a new line. And then it's going to be an any. Okay, I think I've heard about this in the book, which is a common idiom. Wait, where did I put the editor? There it is. Right here. Oh, it was in the parser thing, parser rules. Right here, you'll see that we actually use this. If it isn't this, then anything is fair game. So we're going to have to do a test. And then it has one of those pluses to match everything. If head, it's a KWF, then a dummy then or a new line. Wait, so what you're telling me is that the dummy do and dummy then work to actually silence the semicolon, then figure out a do or figure out a then, and then go to the next line to figure out the next thing. I think I'm actually going to copy that because I do kind of like that. We're going to have a semicolon after all of our tests. Or maybe we don't need to have a semicolon because we can change the tests to match an expression like here. Parentheses all around, expression in the middle, which is basically the condition, and then we'll figure out how to make the expression be an expression. Okay, but we are definitely going to have to add operations. And those operations, well, they're going to operate on numbers and everything else. If head, if burr. Wow, cicada, whoever is the programmer of this is not very readable, I'm going to be honest. The body of the expression is a command, which is either a command normal, as long as it's not a no less than any. Okay, wow. This grammar is kind of a mess. I'm going to be honest, yeah, this grammar is kind of a big ass mess. So if head, it's going to have an if head with the test and the new, and then it's going to have an expression body, and then in the body it's either going to be a command or an expression if, but I thought we already had an expression if. Oh, that's recursive. It's recursive, you can see that. It's a recursive one. It can either be an if or an if in an if. Or it can be an expression while, which is a while loop. Where is it? There it is. and then it's going to have a while head. I think we're just going to have to copy this. I'm going to be honest, I think we're just going to have to copy the grammar of this developer. That's all we have to do. Keyword if, keyword fee, keyword for, keyword else. That's what KW means. Okay, currently we should have defined the keyword string, but I honestly feel like my stuff is a lot less readable than whatever the developer of Cicada has written. So we are going to say keyword if. How about it? Then it's going to have an if. Oh, it has to be in these things. We're going to define a keyword if. That one's done. I'm not going to add an extra space because we are trying to not rely on the spaces. Then we're going to add a keyword then, which is very simple. Just a then right here. At the end, before we get to the end, let me define keyword else if and then. I really wish they had autocomplete here. Else if, keyword else. Oh, I messed that one up. Else, and after that's done, we're going to have a keyword end, which is simple enough. It's just going to be an ending to whatever we're trying to write. Here we go. Not like that. Like this. What other keywords do we have? We have a done as well, but let me see how Lua handles loops. When we're doing loops, we are going to have an end, and then we have something called repeat until condition, but I don't think we really need to get that repeat thing. We also have this for KV in pairs, which I'll definitely have to add that because pairs is such a powerful idiom in programming. What the hell are lookups? What? Metatables? Oh my god! It's simply a table with functions in it. I'm terrified. I don't want to add classes. I don't want metatables. I just want tables. Relational operators. Oh my god. Okay, well that's a lot more complex than I thought, but whenever we add the simple syntax at the beginning, this is just basic syntax. The rest is just a implementation thing. It's nothing that we have to be worried about. Keywords. I'm thinking we'll add keywords for the loops as well. While do. It's a bit of a pain how these languages use do instead of curly braces, but because I'm trying to closely recreate Lua to a point, I have to deal with it. So we're going to have to do a KW while, KW for, KW. Or it's dummy actually. Yeah, let's change it. Let's change the keyword for then to, where is it? Dummy then, dummy do. We're going to add that. And then we're going to do dummy then. Here we are. So we're going to add this and then for the dummy then or dummy do, we are going to do what now? Say what now? It's going to be a then and does it need to have a new line after it? I don't think it has to. Yeah, because I really want to move away from that. Whatever the hell it is. It's like you have to use indentation, you have to use that, you have to use that. I don't want to use indentations. But we also don't have any curly braces or whatever, so I guess we have to. How about end Is that also a dummy thing? Oh, it doesn't have end. It has a fee. Okay, well, we're going to keep the fee. Else if, while for do done. While KW4. I think that's enough. Yeah, KW done. But isn't done also like a dummy thing because it denotes the end? No, well, I don't think it is. Well, if it's dummy, well, then we can just forgo it later. But KW while, we're going to silence it and put the string here. While. Then we're going to do this. Keyword for. And right here. Keyword done. All right, our keywords have been defined. Now this is where we actually have to define our syntax for the conditionals, which is going to be problematic because I don't think parsing a whole language with a single parser is a very good idea. But I haven't even gotten to the programming part yet, and I haven't even read the syntax, not the syntax, the documentation. Yeah, I haven't even read the documentation. Prefix, postfix, infix. Yeah, I haven't even read the documentation to be able to figure out where do we need to use what code, where we need to make a new parser. Well, we'll cross that bridge when we come to it. Let's just figure out the grammar for language. All right, cicada. So cicada, if it wants to have an expression of if, it's going to have an if head. I'm definitely ripping them off, but like, I have no other choice. Please forgive me. It's going to be a keyword if. Then it's going to be the test, which is the condition. But instead of naming it test, I'm going to be name it condition because we're quirky like that. And afterwards, it's either a dummy then or a new line. But for us, it's not either or. It is definitely a dummy then. Condition we haven't yet defined, but condition is pretty simple to define. So does the condition silence? No, the condition is not silent. The condition, in fact, right here, it is an expression surrounded by parentheses. Let's just do that so we can get something out of it. Now we are going to run the rule if head on top of it, if I can find it. There it is. If head condition expr ident condition. Okay, we have an expression here. We have an ident, and then we add to that ident in that condition in that expression. But if we want to flatten the condition, we're going to put that sigil behind it. And as soon as we do that, well, we get an error for some reason. How about this? Expected add, divide, multiplier, power, subtract. Let's not do that. Let's not do that. A condition is way more than just that. A condition has to have a left side and a right side. It has to compare. But instead of comparing it like that, let's copy the operation that we have up here. Then bring it down and add the operation right here. Now, what do we have as conditionals? What do we have as conditionals? The conditions, Rust, not the game. In fact, by Rust, I mean this thing, Rust programming language. Right here. The game we're actually making this programming language for is DDA, which is a rather unheard of, if you don't follow my channel, game. But this is the programming language that we're going to be programming in. And this language that I'm currently designing, it is being programmed in Test, which is a library for the Rust programming language. Yep, That is basically what's happening. And what we're actually basing that off of is the Lua programming language, because the developers of the game decided to remove modding capabilities for Lua and add their own language, which is just a mess. And I hated that decision. So instead of going and complaining about it, I'm making my own programming language that's similar to Lua. But so far, we've already got variables implemented, at least the parsing aspect. Then after it, we're going to have to implement the tree walking, etc., etc. But up until right now, I'd like to think that we're doing pretty good. So the conditionals in programming, all the conditionals that are supported. I swear if it tells me I have to turn off my ad blocker after I go into this. Hopefully not. You know what? Not worth it to check it out. Instead of doing that, we're gonna say comparator. Yeah, we're gonna add a comparator. And the comparators that we have are smaller than, greater than, exact, equals. How does, wait, good question. I really wonder if it was like this or like this. I forgot. But yeah, we're gonna do this and this. And then what else did we have? We also have a not. Or actually, did we have like... I don't remember. Let's go to github.com, Clever Raven, Cataclysm, Dark Side, to actually see the syntax that they use so we can replicate that syntax. With Lua, after we replicate it, I'm going to go into the conditionals, and in the conditionals, we're going to be able to fix it. Just treat it like that. And amidst those conditionals, there is going to be support for expressions. And the expressions, well, it's kind of a mess. But we're going to go into data, and we're going to go into mods. We're going to go into